This is Kayla Bruckman, and I'm working with Ava Cross. The topic we are covering is exploring bivariate data 2. We will go over how to read computer outputs, form a least squares regression line, learn about residuals and residual plots, and interpret the slope, y-intercept, and residuals from a least squares regression line. Here is an example of how a computer output looks. A computer output allows us to see the y-intercept, slope, and standard deviation of the slope, t or z values, p-values from significance tests, standard deviation, and r squared. If you have a TI Nspire calculator, these are the steps for calculating computer outputs. First, go down to Lists and Spreadsheet, and then insert all your x values in the A column and all your y values in the B column. I'm using random digits right now. And then you have to name the columns, so I normally just name the A column lowercase a and the B column lowercase b. Then click off and go to Menu, down to Statistics, over to Stat Calculations, and then down to number 4, Linear Regression. Then the X list will be A, your Y list will be B. Then you can skip all this and go down to OK. And then in column C and D, you'll have all the necessary values to make a least squares regression line. A least squares regression line is a line that makes the vertical distance from the data points to the regression line as small as possible, which means it makes the sum of the squared residuals as small as possible. Don't get this confused with a regression line, which describes how a response variable changes as an explanatory variable changes. The least squares regression line is y hat equals a plus bx. Y hat is the predicted response variable, A is the y-intercept, B is the slope, and X is the explanatory variable. Always remember to put a hat on top of the Y to indicate that it is predicted. Here's an example of a least squares regression line from the computer output from slide 2. A residual is the difference between the observed value and the predicted value, y minus y hat. When we look at a residual plot, we can determine if a linear model is appropriate for modeling the relationship between the two variables. A residual plot is a scatter plot of the residuals against the explanatory variable. When there is a distinct curve or pattern on the residual plot, a linear model would not be appropriate. In the residual plot shown above, there is a random scatter with no pattern, which indicates a linear model would be appropriate. This residual plot has a distinct curve to it, which indicates a linear model would not be appropriate. Residual plots have a line at residual equals 0, which allows us to see whether the predicted value was higher or lower than the observed value. Lastly, we will interpret the slope, y-intercept, and residuals from a least squares regression line. The explanatory variable in the least squares regression line shown is miles driven, and the response variable is price in dollars. The general interpretation of slope is, for each additional explanatory variable, the predicted response variable will increase or decrease by blank. In reference to the least squares regression line shown, the slope b equals negative 0.1629 tells us that the price of a used car is predicted to go down by $0.1629 for each additional mile that the car has been driven. The general interpretation for the y-intercept is the predicted response variable when the explanatory variable equals 0 is blank. In reference to the least squares regression line shown, the y-intercept A equals 38,257 is a predicted price of a car that has been driven 0 miles. For additional practice, check out number 5 on the 2011 AP Statistics FRQ test.